Okay, well, there we go. Thank you, everybody, for joining us today. And I hope you're having a great build. I hope that this new digital build is in some way substituting for the build that you hopefully know and love. But also, I have held out a hope that this new way of doing build that we're forced into at the moment gets us talking to a lot more people. So if you've never been to build before, it's great to see you here. I hope you're having a good time and still learning a lot of great stuff. My name's Glenn. This is Ryan.
Hi, I'm Ryan. Thank you for welcoming us into your home or wherever you're watching this from.
Yeah, thank you for watching. Today we are going to be looking at cloud native applications with .NET and Azure Kubernetes Service, hereby probably known as AKS, because we don't got no time to say Azure Kubernetes Service over and over again. The plan here is that I am going to start with kind of basics. I want to do getting started. I want to talk about how to set up a local environment if I want to build some new cloud native applications, and then we're going to get into more advanced stuff with Ryan, where we talk about diagnostics and observability and a bunch of things like that. And is that about it? Do you have anything else you wanted to say, Ryan,
Yeah,
before we get started?
we're gonna get started. We're gonna get started. We're gonna be talking about local development and what are some of the problems you encounter when you try to build a microservices kind of application. And we're gonna start with Hello World, right? Basically Hello World for microservices. So take it away, Glenn.
Yeah, no, I will do. Let's switch to the slides. So throughout this talk, we'll be talking about how to simplify a lot of these things with Thai, and we'll get more into what that is as we go. But let's do getting started. So our very first basic application is a web app that talks to an API. I think tied into that definition of cloud native is that you want to have two things. You want to have apps that talk to each other, and so this was as close to Hello World cloud native as we could conceive. And so I wanted to set up this web app that talks to a web API, and I did that over here in this Visual Studio Code instance that I have here. I have a front end folder, I have a back end folder. So the front end is a .NET New Blazor application, the back end is a .NET New API, and then I had to go through a number of kind of not necessarily obvious steps in order to get this local environment up and running, so I can just run this app and I can debug it and do what I want to do. So the first thing is I needed to configure my IDE, or VS Code if you don't want to call it a VS Code and IDE, to run both of these projects at the same time. So in VS Code's case, that meant I need to come in here and add a new configuration to launch settings and create this compound launch configuration to run both at the same time, and an associated build task to make sure. By default, the automated experience in VS Code only creates one of them, so you just need to go get it to do the second one. In Visual Studio, there's kind of a screen for this. You can go and launch multiple projects at the same time. But you need to do the short answer thing is get my tooling to run both projects at the same time when I press F5 and attach the debugger if I can. The second thing, which becomes obvious as soon as you do the thing that I just described, is by default, those two apps are both going to be listening on the same port, and they're going to conflict. So in properties, in launch settings.json in here, this is how .NET kind of defines what URI it's going to be listening on, among other things. If you're in Visual Studio on Windows and you're using IIS Express, you're probably mostly insulated from this because we pick a random port with IIS Express when we're creating this file. But if you're using VS Code or any of the other ways of launching your app, you're going to be using this setting, which is going to be hard-coded in here to be the same value for all projects. So you need to change this port to something different. It doesn't matter what, it just needs to be different. And if you're not changing these ports because you're using IIS Express, you need to take note of this port, because the very next problem is the front end needs to know the information that you put in here in order to be able to talk to the back end.
There's a lot of numbers to keep track of.
There's a lot of numbers to keep track of, right? So you need to basically hard code all of these. I mean, it's in a config file. It's not technically hard coding, but you need to configure them. Then you need every app that wants to talk to this app now needs to know this. So what you end up with is, in my app settings for my front end, I now have a URL which copies that value over. so that it knows how to talk to the backend. And then in my startup CS, I'm using HTTP Client Factory. I'm just grabbing it out of config and passing it in so that I can talk to my backend weather forecast service in this case. The problem here is kind of as you grow, as you add more and more stuff, suddenly you end up with these long configuration files with many, many URIs all pointing to all the other services you need to talk to, and God help you if you change some of the ports around. And so this problem, kind of in the cloud native space, is more generally talked about as service discovery. And so there are some solutions out there in the cloud native space, but that's effectively the problem that you're hitting up here: is how does one service find another in your local dev environment. So I said we were going to do some stuff with Thai, and so what Thai does is it helps solve some of the problems that we just went over in that setup, to make those a bit easier, to smooth them a little bit. And so I have this Thai global command here, and we'll talk more about how to get this and stuff as we go. But I'm just going to do Thai run in the directory where my solution is, where my front end and back is. And what this does is it spins up this URI, which gives me a dashboard. And if I look in here, I see, okay, it's ran my front end CS proj, it's ran my back end project, and I can navigate to I can navigate over to, that's my API. So I go /weather forecast, and I get some weather forecast data. I can navigate over to my front end, and I can see my front end, and I can navigate around, and it can fetch some data and stuff like that, right? So Thai then, with just a solution file, it solved most of the problems that I just hit, except for one. The one it didn't solve is, see this page, it's trying to load data. I've got an exception here because it's trying to load data from this backend, but in this demo flow so far, this is still configured for being used without Thai. So I showed you kind of how you would manually do this by saying, get me the URI from config. And this works for local F5 right now if I was to F5 this. But when I'm using Thai, we take care of setting up some things for you. And as such, in here, I can say configuration.get service URI, and I just give it the name of the service, which is the name of the project. So I can say backend, right? And so this is effectively codifying and automating that process that we just talked about, where when using Thai to run your app, it tells your app what ports to use so that you're never going to have the problem of them conflicting, and it tells each other service what those ports were so that it can go find them without having the explicit configuration around, right? So this is the only step that's required here. All the other stuff that I said I did, none of that's needed anymore if I'm going to use Thai, because now I can Thai run and I can see my dashboard, and my apps were all listening on kind of whatever port they were told to listen on, and I can go and browse around and fetch data, and I can now talk to now the services know how to talk to each other. All right, and that is a very quick, whirlwind introduction to how we've observed a lot of kind of boilerplatey, I guess, for lack of a better word, things that people need to do when just getting started with building a cloud native app, and tried to ease them with tooling experiences with developer tooling. And so this is our kind of reminder. We saw multiple project startup. It's a little bit easier in VS than VS Code, but it's fine. We saw some service discovery stuff. The key point there is that manually doing a bunch of configuration is pretty fragile, and it can get hard and difficult to manage very, very quickly. And then the third point, which I didn't talk about, but is kind of the next thing, is what about when I need to talk to a SQL database on that weather backend or something that isn't my code? What do I do then?
Yeah, I think some of the important questions would be, well, we can launch our applications from Visual Studio or Visual Studio Code. What about launching a Docker container with SQL or Redis or something else that you need to talk to?
Yeah, and so is Docker Compose the solution for that? If any of you have played around with Docker and Docker Compose is a way that you can kind of do a lot of these things. It can help some of these problems on your local machine. It has but it also has a very steep learning curve, and it kind of only partially solves some of them, right? Like Docker is a phenomenal way of publishing something like a SQL and pulling it and me being able to pull it down and run it without actually installing SQL Server on my machine. And it's an amazing way for me to package and deploy my applications, and it's amazing for lots of things. But for the local dev experience, we still felt there were a lot of kind of rough edges on the Docker experiences as it started today. And as such, we started to work on this TIE experiment. And so what you've seen is TIE consists basically of service discovery via configuration conventions. So you saw that configuration.get service by name code. It understands all your .NET project files. Like all I did was run TIE run on a solution. So because it deeply understands .NET, it's capable of doing a lot for you. And we're going to see more of how that benefits you in a moment. And then it gives you a good dashboard with logs and metrics and everything locally. We didn't really look into that, but I'll show it to you in the next demo as well. And it can run Docker dependencies, and it can Dockerize and deploy your application to AKS, is what TIE does. So let's skip forwards a little bit, and let's talk about this next application that I'm going to show you. And it is a much more complicated app. And so it is if any of you have seen the Blazing Pizzas application, this app is taking the Blazing Pizzas app and like kind of cloud native-ifying, for lack of a better word, the back end for that. We have it has a front end. This is kind of a more conceptual diagram than a kind of physical one, in that the front end is basically two parts. It's an in-browser Blazor client app and a backend API, and that API then talks to your PC to all these backend components. You have a menu service, an order service, a delivery service, and they all have different data stores. They're all just separate from each other. And you can see by the coloring here, you have kind of your front end, which is what everybody interacts with. Then you have this middle tier of services that everybody interacts with, and then a bunch of green. Now these green things are all dependencies. They're not part of my app. And that's exactly what we just talked about, where how do I handle this? Today, do I need to go install SQL Server on my machine and Redis on my machine? What happens if Orders uses a different Redis? Like, what do I need two different Redises if I have two different versions? So on and so forth. So let's skip then back over to my demo. And now I have Docker. Now I have Docker up and running. We can try that again and say TIE run, and see if it works this time now that I have Docker. And so the reason that Docker is essential here is because this application has so much more to it, and it uses Docker to be fast. So as you can see here now, look at all this stuff. I have a front end, I have orders, I have delivery, I have a menu, like I have 3 different SQL servers, I've got a Redis, I have this thing called Ingress, whatever that is, I don't even know, but it's amazing, right?
Yeah.
So
now, Glenn, are your services there? I can see there's like 5 of them.
Yeah.
Are those running in Docker, or are they running just like normal .NET processes?
They're just normal .NET processes. So one of the advantages here is TIE has taken care of running these databases for me in containers, so it's interacting with Docker on my local machine. But these services that are part of my project, things that are CS projects, are not running in containers, which means instead of kind of F5ing in here, this is not the VS Code that I want. Instead of F5ing, I can attach, basically. Rather than I can just run this, I can TIE run my app, and I can attach the debugger, and everything is fine. And we can look at that in a moment. So I'm going to give you a brief tour of this dashboard. Then I'm going to go back and we're going to look at how was it that TIE knew about all this stuff. So the first thing that we can see in here is I can view the logs for each of my apps. You can see, including like my databases, you can see this is SQL Server booting. So this is SQL Server running on Linux in a Docker container. This is Redis that is spun up, and this is Redis running for me. This Ingress is configured to just say, okay, take and make up a new URI and just point at the front end at that. So I can, on my local machine, kind of simulate what you would have in a production environment, which is a single URI that comes into my front end, and then my front end goes and does all the things. And so from here, I should be able to come over here now, and you can see I can browse to my local like pizza place. I can go order pizzas, and I can look at my pizza history and stuff like that. All right. So, and then one other cool thing, cool thing is I can click this, and this actually shows me metrics. So I can see all of the different stats that we collect about this process as it's been running, which might be really useful if you're trying to diagnose a few particular types of bugs that require some of these metrics, like perhaps thread exhaustion or something like that, right?
So if you've seen .NET counters, if you've seen a show or talk about .NET counters before, this is basically .NET counters in the browser, but for all your services at once.
Yeah, and so if I do a Docker PS here, if I make this big in this, you can see I have all of these containers, these associated backend containers running, but my application isn't in those. So now what else is super cool now though is Control C, right? Let it, and then everything spins down. So Thai run, I just started 3 SQL servers, a Redis, a bunch of networking stuff, and all of my .NET processes that are just normal processes, so it can just attach to them like any other process. Control C, and all that stuff is gone. Right? So at this point over here, as I do a Docker PS, like there's no more SQL running on my machine. It's gone. Right? Which is amazing. Like it's clean and it's nice. And so let's start up code and let's look at how we did some of this magic sorcery. And this is, so first of all, I told you that said that I would show you, kind of forgot, .NET Core attach. So after you've done Thai run, you can click play in here, and the next time I do Thai run, I'll try to remember to come show you, but you can click play, and then in here you'll see the like front end, back end, so on and so forth, and you'll be able to attach to them if you desire. But in this case, because I had dependencies, so if you don't have dependencies, you can do what we did in the previous simple application where you just Thai run and you have a front end and a back end. You probably saw, so you might have seen some of this in Scott Hunter's talk if he did it. I'm not 100% sure how far he goes when he talks about Thai. He does show it, but you may have seen some of this. But when you have dependencies, you need to tell us about those, and you do that via this thing called thai.yaml. So in this file, I have defined the name of my thing, my Blazing backend, and I have defined where the CS projects are for each of the services. And then down here, I define where each of the databases that I'm going to need. And so in this case, what I did is I actually specified a whole complete database instance for every individual database that is part of the solution. And they each have their own connection strings that flow through. They each have their own connection strings that then flow through. The ports are automatically flowing. If you think back to our problem earlier on where we had that one manually defined port with a URI, now think about the front end has several services that it talks to, so it now has 3 or 4 different configs that it needs to talk to. A lot of the services then have databases. They also have more configuration they need to talk to. There's just lots and lots of config files with lots of hard values floating around the app if you're not using Thai or something like Thai that could solve this for you.
And what a lot of people do that seems successful is you end up with your team sort of making a scheme for how you use configuration, right? You end up defining a style where we're going to structure our keys like this. We're going to name things like this. That's really what Thai is doing. We're auto-generating things like port names and stuff like that and auto-assigning them. So you literally cannot hard-code them, which is great for an app that you intend to put in production somewhere.
Yeah.
Just let the computer deal with it. But it's really, the service discovery aspect is really just kind of us doing for you what you would probably be doing today anyway, which is coming up with a way of organizing this data.
Yeah, and if we go in here to here, this is how we get the connection string is actually literally the same as you would get a connection string today, because we already know we know how to work with the .NET configuration system. Right? So this code actually would be no different if you put it in a config file versus having injected it in via Thai. It would all still work. Or this string might be different depending upon how you did it, but otherwise it will be the same, right?
Now that Thai YAML was pretty big, and it has your project files and stuff. Is there a way to generate this file?
Yeah, so when I got started here, I had my CS proj of all my solutions. I did a Thai init, and it gave me this bit. with all of the stuff that it could discover from .NET, and then I added in the databases that I needed because it couldn't determine those. But otherwise, but yeah, there's a tie init command where if you point it at an existing solution, it'll work out everything it can.
Cool.
Okay. And ingress here isn't required. I chose to do it because I kind of want it later, but and it gives me that new URL that points specifically to a service. But this is how you say on this port, direct whatever path to a specific service. And so at the moment, because of the way you would want to deploy this app in production is I go to / and then it goes to the web app. That's what I was trying to mimic via that one new URL. It's like optional. You can choose to use it or not. I kind of like it there.
I mean, one of the aspects of the tie philosophy that I think people are going to find helpful is that we try to move your development scenarios to be a little bit more like production. So we try to give you the things that you're going to have in production as much as possible so they can become part of your deployment environment. So if you're using Kubernetes, it's a very typical thing to do in Kubernetes to put a proxy in front of your cluster, and don't generally expose your services directly to the internet. You put a proxy in front of them and do routing by hostname or something like that. So we can actually give you that at dev time, which is what the ingress is for.
Right. Now, we're going to go into some deployment stuff now. Ooh, look at that. Somebody cleaned up after themselves, which is very nice, which is what that check was just for. So now I'm just going to say tie deploy, and I'm going to go -i. And so what the -i here means interactive, so that the command is going to prompt me for information if it doesn't know it. And all I've done here is configured my local kube command line, kubectl, to know how to talk to the cluster. Is basically all I've done pre this. I've basically done the auth dance so that I can authenticate with a cluster. And so this now is going to take my local app that I was just using tie run for, and it's going to try and take it and send it to an AKS cluster. So this string that I'm putting in here, in this case I'm saying Glen C, which is my Docker Hub username, and that means that I'm going to use Docker Hub as the registry to store the intermediate images. And what I mean by that is what's happening here is Ty is taking my .NET projects without me knowing about Docker files or how to Dockerize them. It's generating Docker images for them, publishing them to Docker Hub, then taking those Docker Hub images and publishing them to Kubernetes for me. So,
Can we prove real quick that you don't have that stuff?
that I don't have what? Which stuff?
Docker files and Kubernetes manifests.
Oh, yeah. Back in here, yeah, there's no Docker file. Oh, there is Docker files actually in the project, unfortunately. You have to take my word that we're not using them, but they are here from a previous iteration
You
of
could
this
delete
demo.
them and that would still succeed.
Yeah, I could delete them and this would still work. And then one of the things that you get prompted for here is the Ty knows that you probably don't want to deploy your local database Docker container to the cluster. And so it's prompting me for connection strings, and I'm going to copying and pasting these connection strings in, and it is going to create those as secrets on the Kubernetes cluster and then use those from here on out. I won't have to specify them once they've been specified once, but it will create Kubernetes secrets for each of these, and then each service, when it gets started up, will load those automatically from the Kubernetes secret store, and they'll be in the app and ready to go. So in this case, we're using Azure SQL and Azure Redis Cache to be the data sources, and all of my applications would run in AKS, which is what we would kind of recommend. In general, running a database on the cluster is pretty difficult, and we would not usually recommend that most people do it.
Yeah. So some of the other options for this, I think Glenn mentioned that it would save those with secrets. It's a one-time thing. Basically, if the secret exists, then Ty will just continue to use it. And the normal Kubernetes secret, so there's nothing arcane or proprietary kind of happening here. If you've got a little bit of experience with Kubernetes, or if you've used the very excellent VS Code extension, which I recommend, you can easily browse, delete, edit, save, create, all these kinds of things, and just manage them like normal secrets. So some of your other options would be, you could generate the list of secrets ahead of time, provision those, and then do an automated deployment of your app and not have to be interactive.
Right. And so now if I rerun this kubectl command to get all these pods, you can see all of my stuff is now running. And in fact, if I do this one, right, and then I say get pods ingress and nginx. So when I set up that ingress command, it didn't prompt me because I used m instead of n. The cannot type for the life of me.
The
The
ingress is already there, right?
It was already there, which is why it didn't prompt me, which is why. But what I was going to get to here was say, can you show me the like port based the IP basically? What that meant, what that set up for me automatically was this IP address. So now I can just kind of test out that everything works by browsing to my remote cluster. And this means now I have my entire application in containers in AKS, and running in very very short amount of time, which is
Yeah.
super
So I
cool.
think the one thing, I think just in case anybody missed it, the one thing that was pre-deployed here on this AKS cluster was the Nginx ingress controller.
Yes.
If we had completely reset the cluster, Ty would prompt you and ask you if you wanted us to do that for you. So that's pretty new. It's one of the things we're working on is like, what kind of things can you need that we can set up for you? And ingress is one of those things.
Yeah. And so that's going to end my like whirlwind introduction to all things Thai and deploying to AKS. We've got about 18 minutes left. So in that time, I'm going to hand it over to Ryan to talk a lot more about diagnostics. And so first off, I think you wanted to talk about observability. So we have this observability slide.
Uh,
So we think observability and diagnostics are critical for cloud native applications. Your code. If we think about, we said this like most basic of cloud native apps was your code running on a cloud isn't as easy to log in. Like it is two apps, right? But then you've also deployed it to the cloud. Now that my thing is in AKS, how do I talk to it? How do I connect to it? Like it's not really easy or possible to log into. Your things that used to be a method call within my one application are now going over HTTP to some other machine, maybe even some other database cluster, like maybe even some other like data center, right? They're a lot further apart, which means observability and diagnostics become even more important now than they ever were in the past. And then if we talk about a few types of observability, we want logs, metrics, and distributed tracing. Logs and metrics are things you probably have before. How do I get my logs? What's important in cloud native is you kind of want to centralize all of those. You want them all to go to one place if at all possible. So that you can see all the logs in one location. You really want metrics to be able to monitor the health and performance of your application. Both, is my application healthy and capable, and is it like within SLA and servicing my customers, as appropriately as possible. And then distributed tracing is how do I correlate something that happened in the front end to some error that happened in the back end, for example. So I can start correlating actions through a set of services. And now I am going to switch you over to Ryan's machine, so now you can all see his glorious machine, and he's going to take it away.
Do I have control?
You
I have
have
control.
You have the control.
Great. So I've got the same application here. Glenn and I are partying sort of on the same thing. And the only thing that I've done here that's different is I've added some extensions here. So I've said I want Zipkin and I want Elastic. And we're going to find out together what those things are in a couple minutes. But I think you know the idea since we're talking about diagnostics. So I'm going to go ahead and do a Thai run and spin all this stuff up. And you'll notice as this is coming up, there's going to be some output here that's kind of specific to those things. So I've got this dtrace using Zipkin at URL this, and then I'm using Elasticsearch at this URL. So what's happened here is basically because I've got those extensions, I'm adding Zipkin for distributed tracing, and I'm adding Elasticsearch and Kibana for log aggregation. So let me go to my Thai dashboard, and I can prove this. So I've injected Zipkin and Elasticsearch container. Now these are external projects. These are like popular open source projects that you can use for your own stuff. And they're not really connected to Thai. The only thing that Thai's done here is I've used Thai to sort of put these into my application. So I don't have any dependency on any of these kinds of things. I just started seeing them show up here because I asked for them by putting the extensions there. So let's go to the app and let's generate some traffic. Here's my Zipkin dashboard. And right now, if I search this, you see that there isn't anything there because I haven't done anything yet. So let's generate some traffic. And we're going to order a pizza because I'm getting kind of hungry. It's almost dinner time here. And I'm thinking pepperoni today. And I'm thinking pepperoni with hot peppers sounds really good because just pepperoni is not spicy enough. So let's order pizza. I'm going to very carefully put in my exact address. So if you need to reach me, just I guess send me a letter to this address, and I'll order that. And it should just take a second here. So now my pizza is being made. I can see that the status is preparing, and should hopefully start being delivered soon to my location here on the Thames, because this is left over from the Blazer workshop. So this should start. Okay, there it goes. So my pizza's just left and it's on the way. And I'm kind of thinking while my pizza's on the way, I'd like to see what's going on with the website. So to sort of understand this, I can do a search here now in Zipkin now that we've generated some data. And you can see that I've got all kinds of interesting stuff here. I've got all kinds of interesting traces, often involving a bunch of different services. Like you can look at, here's the set of interactions that happened when I queried the menu to get the list of toppings. So these things over here are called spans. The Blazor WebAssembly application made a request to /toppings. Then the front end service did an HTTP request outgoing or a gRPC request to the menu service, and then the menu service handled that request. Likewise, I can look at what happens when I query the order status. So querying the order status here, you can see the front end made an HTTP call into the order service to get the details. And then it saw that the order was still being delivered. And so it made a query to the delivery service to say, hey, where's my pizza? I want it. The other cool thing that I can do with this is I've got a trace ID. And this trace ID is something that's a piece of context that's shared amongst all these spans. So basically all the code that's running in all my services are all going to see the same trace ID for all 3 HTTP requests that happened here. And so the really cool thing that I can do with that is I can come to my log dashboard here, and we can build a query to look at what happened for this trace. So this is Kibana. This is an open source, popular sort of tool for looking at logging. And I've got all the logging from all of my services all going to sort of the same sink here so that I can query these things together. And I'm just building a basic query to query across this trace ID. So I want trace ID equals to, I say is for equals to, and search it. And then you can see here I've got 8 hits. I've got all the log messages across different services that were associated with this trace. And so that's kind of cool. You can do searching across different services to see what was involved, exactly what happened. So if you think about like, what are the kinds of things that you deal with? What are the kinds of problems that you have to solve with microservices development? Well, something blew up. You have a request ID. I need to know where exactly in the process it failed, or where exactly in the process was it slow? Did it fail at this service? Did a retry happen? What was logged? So having tools like this and having them available to you really helps you sort of scale up or mature up your development process as well as your production debugging process. And I think having these tools in development, because we're in local development here, and giving you similar tools to what you can get in production really helps you sort of build those muscles and start to think about like, okay, well, I'm going to add logging to my services and then immediately get diagnosability. The other thing that I sort of think about when I think about these logging and tracing scenarios is, well, what about the code you don't own? Do you need to run services that belong to another team as part of your workflow? And how do you understand what's going on inside those services if something goes wrong? So one of the other cool things that we can do with Thai is we can actually deploy this as well. So we'll go ahead and give that a try. And this is just shutting everything down here. Takes a while to shut down because there's a lot of things to shut down. It's a lot of containers and stuff.
I mean, there's a lot of stuff behind the Zipkin and Kibana. Zipkin and Kibana are several different containers all running at the same time, right?
Yeah.
Not to mention the 3 SQL servers and the Redis database, plus all of your apps.
Yeah. So we're going to do a Thai deploy. And again, I'm doing interactive because there's going to be some information to fill out. And I'm going to use my Docker Hub because I don't have Glenn's password. But maybe I should get it. And then the other thing is it should prompt me here for some information because I should need to deploy. I should need to be able to point.
You can see there, just one interruption. You can see there it found all the secrets from when I provisioned that stuff earlier, because we are deploying to the same cluster. So it already discovered all those secrets that we copied and pasted in last time, so we didn't have to do that again, which is cool.
Yep. And now I've already got Zipkin running here, and I've already got Elasticsearch and Kibana running here. I've already deployed them to my cluster. And I'm just going to paste in the URLs of these things so that Ty can find them. Um, and so this makes sure that when these applications get deployed, we'll actually be able to talk to my Zipkin and my Elasticsearch that are running in the cluster. Now, these don't have to run in the cluster. They could be some other URL. It could be hosted somewhere else. We don't really care. The only thing that Ty is doing here that really is significant is we're concerned with how this data gets into your application. So we understand the .NET configuration system. We have a design for sort of a pattern around service discovery configuration keys, and we have some helpful like extension methods on configuration that you can use to query these things and to access them in your code. So we're really just concerned with making sure that all the glue stuff and all the plumbing stuff gets wired up in the right way. So that's deployed. Let me check one thing. Let's do get pods here and see. So you can see that it's shutting down all the instances of everything that's already there and spinning up new instances because the data has changed. And so I'm just going to watch this for a sec. Just make sure that let's just make sure real quick that stuff has actually spin up. Oops. And this is the reason why everybody who does a lot of Kubernetes work tends to have an alias defined for kube control so that you don't fail when you're recording something or when you're on live. But if you have an alias, then people can't see what you're doing and it's confusing. So the other thing that I'm going to do is I'm just going to get the service. I'm going to get the IP address for Nginx because I forgot to save it so that we can hit our endpoint. So this is our public IP. And as we mentioned before, we have ingress configured for this. So we should be able to hit this and do some traffic. So there we're getting to our website. Now I'm going to do the same thing. I'm not going to make you sit through me having a pizza delivered again, but let's just do some queries and do some things here so that we generate some interesting traffic. And then we can look at, can we actually touch those things running in the cloud? So I've got a little script here. I'm going to port forward to Zipkin, and you can see the command that it's running there. And now, don't let this part trip you up. We were accessing Zipkin locally with localhost 9411, but since I've done that port forward, we're now accessing Zipkin running in my Kubernetes with 9441. That's the sort of standard preferred port for Zipkin. So we've done a refresh, and you can see that we've got some tracing happening here. This is me clicking around in the menu, looking at the list of toppings, and we've got these distributed tracing things happening for us in the cloud in our deployed application. Let's try Kibana and make sure that we've got logs going there. So now we're port forwarding to the Kibana service. And again, this says localhost, but it's actually port forwarding to my real cluster. These things are not something you would typically expose to the internet, or at least not without authentication, because this is a demo. I don't have any authentication configured, so I'm just kind of cheating here. And looks like we might have had something go awry here because I don't have a index pattern. Okay, there we go. Just needed to catch up. I think Elasticsearch was chewing on something. So I won't repeat what I did before, but you can see clearly we've got the same kind of data here, right? We've got our logs showing up. If you've looked at ASP.NET Logs before and you see these sort of string and key value pair template things that happen with logging, if you wondered about the value of that, it means that all the key value pairs and all the parameters that you pass into logging, like the elapsed milliseconds or the type of action result, all become things that you can query on when you're doing structured logging. So when you want to do more advanced stuff, our logging system is kind of oriented around these sorts of things already. So that's mainly one thing I wanted to show, and I think there's one more thing to see, which is tie undeploy. If you want to throw something away that you've put in deployment, we have a command that will just delete everything.
No, all my pizzas, they're all gone.
Pizzas. Well, all your pizzas, you can order pizza later.
Okay.
So that's what I've got.
Nice. Good job. So let me switch us back to the slides. So the next one thing we didn't talk about much, but we do have a slide on, which I've now put on the screen, is how did we get all of those? How did we get all those logs to be? How do we get all those logs out there?
let's talk briefly to how this works. So one of the details here is I didn't make any code changes to get any of these things to work.
Yeah.
So Glenn showed you some very vanilla ASP.NET Core applications. Um, I didn't put a Zipkin SDK in the code. I didn't put a distributed logging thing in the code. Those apps were vanilla from a tracing and diagnostics point of view. So what Ty is doing here builds on something new as of .NET Core 3.0 called Event Pipe. So if you've seen .NET Trace or .NET Counters or any of these other kinds of diagnostics tools that we've been working on, basically you can connect a process to a .NET Core process and kind of spy on it, as long as you've got permission to and you're on the same machine and so on. So if you're using one of these diagnostics features, we can deploy an agent to the same machine, basically running in the same group as your container. And this is, in Kubernetes terms, they call this a sidecar. So we've got a sidecar process running there, and we can connect to your app. We can gather all your logs and all your traces and all those things, and then we can be responsible for forwarding them to wherever your provider is, wherever they're destined to go. So we didn't show metrics today, but we have a plan to do the same thing with metrics. And that's actually what Ty is doing when you do this locally and in production. So when you run locally, we're starting your process, we're connecting to Event Pipe. That's how we populate the metrics in the dashboard. That's how we show you that log display. We do the same thing when you run in production if you opt into it with one of these extensions. And this is something that we're looking to expand in the future and build all kinds of rich things. So you don't have to toil with SDKs, and you can get good experiences for these diagnostics, both running locally on your machine and when your application's deployed, without you really having to learn how to use these tools too much, or I guess learning how to integrate these tools with your app.
Yeah, I think the big key here is like, how do you get started and build confidence while you're learning the tools, right? And Ty aims to really smooth that experience so that you can get up to speed and deploy your stuff really quickly, and then learn everything as you go with stuff that's actually working, instead of having a really big cliff that you have to climb in order to gain the knowledge you need just to get started.
Mhm. The other thing is we understand .NET. We work on .NET. We are the .NET team. So we can build these curated experiences that .NET that are really for .NET that are really optimized around the platform's capabilities. You don't have to become a platform engineer to use it successfully. You can just focus on what's important to you.
Right, which I think brings us to this slide, which is, what is Ty? What are we doing?
Yes.
So Ty is an experiment that we're doing over the course of .NET 5. It's here on GitHub. We're trying to solve local microservices productivity. So like, we want to give you that really good productive local experience for building microservices and getting them up to Kubernetes. We want to and we want to make it so that, as I think Ryan said to me today, we want to provide you a menu that you can choose from, right? So that some aspects of what Ty does should be relevant to you regardless of your maturity level. Some people who already are very experienced with building and deploying microservices to Kubernetes probably don't need. They've already got flows set up, and as such, we're not trying to force Ty into that. But pieces of it we believe are going to be useful. That, like, at least the local run everything at once experience. I would also want to add that Ty, because it's what does experiment mean? Experiment means we're not shipping it. We're not guaranteeing that we're going to ship it. We may just learn a lot and then not. As an example of two possible futures, one is the Ty command could exist as it does today, and that'll keep going into the future, and we turn it into a product and we ship it. Another possible future would be that all of the technology that makes up Ty just kind of gets absorbed into other tooling ecosystems. Like, Ty Run is perhaps just the way .NET Run works in the future, as another example of how this works. So it's an experiment because we want to try solving a lot of these problems. We want to do a lot of experimentation in directions and not be scared of, like, going down a path that proves to be not the way. And then once we get through kind of a year of experimentation, decide at that point, okay, should this be a standalone tool? Should it be integrated with a bunch of existing tooling? What would the productized version of this look like? And then make that call then. So that's why it's an experiment and why we call it an experiment, which means it also means that if you start getting involved today, like, you can help us shape what that looks like at a really early level, at a really early time. Do you have anything else you wanted to say about what Ty was or anything, Ryan?
I think you said it all. I think, experiment for me means trying risky ideas and ideas that we have a hunch might fail because we can learn something. And I think that there's a bidirectional I think that there's a bidirectional learning that happens. We're learning from .NET users what kinds of things they're doing today that they're really happy with, what kinds of things they're doing today that are painful, and we should try to take the pain away. And we're also learning a lot about what's possible or what the cost of building something is or what the cost of maintaining something is, and whether or not it's something that we can sustain as a committed product. You can take risks in a non-committed product. You can't really take risks in something that people use every day and rely on.
Yeah. Excellent. So that leads us to the very end and to the last slide, where we would really, really, really appreciate it if you would go try Thai, do the getting started. This link here, there's a pretty easy tutorial that just lets you do basically the getting started that I did at the beginning of this, and click this button that says "Tell us what you think," and do the survey. That behind that button is a little survey that just tells us what your experience was like. We do look at the survey data to work out the future things that we should do, as well as like prioritizing future areas of investment and understanding what it is that you're doing. So please do the survey when you try the thing.
The other thing you can do if you're really interested in Thai and you want to sort of follow what's going on, we'd love for you to try it out. If you do try it out, or if you think this isn't something I want to try out yet and I just want to follow what's going on here, go to our repo, go to the issues section. There's a pinned issue there that we use as sort of an announcements issue. So you can go there and you can subscribe to that issue, and it's a very low traffic way of getting a notification when we have something to say, when we've added features. We tend to try to talk to you about once every 2 weeks. So that can be a good way to follow what the team is working on and what progress is, if you're interested.
Yeah, that's right. So yes, that's our call to action. I hope this was very useful to you. I hope you're having a great build, and thank you so much for watching and sticking around to the very end. I appreciate it.